This is your brain on risk. This is Mind Over Money, the podcast where Kevin Cook exposes the psychology of investing.
Welcome back to Mind Over Money. I'm Kevin Cook, your field guide and storyteller for the fascinating arena of behavioral economics. In part one of this Chautauqua, I attempted to connect several ideas about technology and science in the light of what we have learned in the past 30 years or so about human nature and human behavior. Note the distinction between human nature and human behavior. Behavior varies widely across cultures where cooking, language, clothing, music, religion, technology, war, and dozens of other customs have incredible diversity. But when we talk about human nature, we mean the root causes and drivers of behavior that tend to be common among all humans as a species, disease aside. These would include brain structure and function, genetic predispositions or programs, in essence, we could call it our software, and various theories and puzzles about evolutionary psychology that inspire scientists to work backwards and attempt to solve for X. In other words, cognitive, behavioral, and social researchers ask questions like, why do humans across cultures experience rage, jealousy, sorrow, joy, apathy, shame, and laughter, and what forces in our brains, our evolutionary past, and our genetic makeup create these natural responses in social encounters? And what about language? Why is that a universal human trait with many similarities of syntax across cultures that have never had contact? We could also add music to this list. Think about the work of Mickey Hart, a longtime drummer for the Grateful Dead who has spent a lifetime sharing and preserving the indigenous rhythms of cultures from around the world. As an aspiring drummer myself, I loved Mickey's 1990 book, Drumming at the Edge of Magic, A Journey into the Spirit of Percussion. As much as any evolution book I read 25 years ago, his work, and Chicago's 1980s industrial dance clubs like Neo, Exit, Smart Bar, and Limelight, confirmed how beautifully connected all human races and ethnicities were by our natural desire to create and enjoy rhythm and percussion. If we have time, we'll come back to Mickey and his brain and music, as he now seeks to find rhythm-based cures for Alzheimer's. This propensity to ask questions about fundamental human nature and our challenges to understand and agree on it are why, in part one, I thought it was important to begin a discussion about brains and weather with a biological understanding of human nature. I used an essay by Steven Pinker to help get us started. That essay was actually excerpts from his 2002 book, The Blank Slate, The Modern Denial of Human Nature. You can find the part of that essay which condenses these ideas on the excellent thinking person's website, edge.org. Just search for the Steven Pinker interview from 2002. I'll also have the link in the article version of this podcast on Zax.com. All right. Amen for brain scans. Now, why would the last 30 years of scientific research be more important than the previous 30 or 3,000 years in our quest to understand what we are, where we came from, and why we act the way we do? Because our knowledge of human nature and behavior has been vaulted exponentially since the explosion of research involving not only paleoanthropology and genetics, but also as much by brain imaging. You need only listen to Dr. Daniel Amen on his own metamorphosis and life's work to understand this. After the Army, Amen finished medical school and became a psychiatrist, the only medical field where doctors don't actually look at the organ they are treating. But he was also trained as an X-ray technician in the Army and developed a love for medical imaging. In 1991, he was able to marry the two fields and spent the next 2 decades building the world's largest database of brain scans. His TEDx talk from 2013 is called The Most Important Lesson from 83,000 Brain Scans. I highly recommend you watch it. Make it your most important 15 minutes on YouTube this week. I'll have the link in the article version of this episode on Zax.com. All right. Richard Feynman would approve of my failings. Talked about Richard Feynman a couple of episodes ago, the physicist who has a fantastic approach to learning. Where he says one of the best ways to learn is just to dive in and then try and teach it to somebody else. So in part one of Dopamine in the Weather, I ran a little over time at 51 minutes. And as usual, It's because sometimes I try to accomplish too much. I try to connect too many ideas in a single podcast. As a result, I also did not do justice to dopamine in my explanation of it. I will repair that failing in a moment. But first, in my defense for trying to string together too many ideas in a single episode, let me say that the threads of the fabric I was trying to connect were already there. They had just been ripped apart by modern technology and society, where we don't learn some of the most important connections in the physical and social sciences because every subject is taught as a separate course with great detail at the expense of deep and wide connections. This is our modern education system that seeks to create specialists first and foremost. That's where the jobs are, after all. And most kids are too busy being distracted by TV, or maybe now it's social media and video games, to get a real and full education in the sciences, even in college. And so, given this challenge, it takes me a while once I get started weaving and reweaving the full fabric of a full education. The ancients, from Socrates, Plato, and Aristotle, to the Buddha, Lao Tzu, and Confucius, saw more connections and wholeness in knowledge and values than the average college graduate of the 20th century. I am holding out hope for the college grads of the 21st century, as it truly is the century of biology and the life sciences. I know. The computer geeks think it's the century of artificial intelligence, but AI will just be a cool tool of genetic engineering. And even if I've got that wrong and the future looks much different than I imagine it, it will be a wild and fun ride for those who are educated in the sciences. And for those who learn to invest in the companies creating the future too, like companies that are using AI, brain science, and genetic technologies like NVIDIA, Bluebird Bio, and CRISPR Therapeutics. But full disclosure, I own all three of those for various portfolios here at Zacks. So my work as a technology investor, a stock market trailblazer, a philosophy teacher, and a science preacher is to keep putting the strings back together into a fabric that makes sense, has integrity, in essence it's truthful, and can be used to make your life incredibly rich. And hopefully we can make some money along the way too. Today, I hope to flesh out my 5 proofs that should convince you to be as open-minded to science as possible and as rigorous in your examination of new technology as possible. All 5 are arguments that prove the average human is at a disadvantage approaching modern society, let alone the technological and scientific future speeding at us. Average kids like me don't get the training we need from our average parents. We'll get to my 5 proofs and then maybe start to tackle the climate science debates right after I do some justice for the incredible, wonderful dopamine. In part 1, we talked about how the anticipation of most types of rewards increases the level of dopamine in the brain, and how many addictive drugs increase dopamine or block its reabsorption into neurons following release, thereby creating addiction by interfering with normal dopamine transmission. What I didn't do a good job with in explaining dopamine is how it is often activated simply by the anticipation of reward, and not merely the arrival of the reward and its corresponding pleasure. This gets more to the heart of why dopamine makes us feel good and what role feeling good has beyond merely compelling us to eat or seek out a mate. And this is massively important because this puts dopamine at the center of attention, memory, motivation, and as we'll see, learning. At the end of today's episode, I'm going to give you a 5-part strategy to learn more, better, and faster than you ever thought you could. Some scientists call this whirlwind of neurobiology that dopamine is central to incentive salience, which is a fancy theoretical description for a multidimensional process that concerns the regulating of desire, attention, and its corresponding motivation. Once our desire is aroused and alerted, dopamine keeps the anticipation going. It's all about the physiological excitement, the wanting of something rewarding and pleasurable that is nearby or available in the near future. This is what sustains our attention and drives our behavior when dopamine kicks in and tells our brains how important something is to us, how good we'll feel once we have attained it, because we feel good even before we have it. So let's break this down a little more. Salient is not exactly a word we use every day, so we'll start there. Salience can be defined as the property of being noticeable or important. In neuroscience, salience is described as the perceptual quality by which an observable thing stands out relative to its environment. So you could also think of salience as the vividness, proximity, or availability of a stimulus. The salience or saliency of an item is the state or quality by which it stands out from its neighbors. According to the Wikipedia entry for salience, as it applies to neuroscience, saliency detection is considered to be a key attentional mechanism that facilitates learning and survival by enabling organisms to focus their limited perceptual and cognitive resources on the most pertinent subset of the available sensory data. All right, so the two words that I really put emphasis on there were focus and learning. And these aspects of attention will be key in my conclusions about dopamine. Let me read from the Wikipedia entry for the larger treatment of the topic on a page titled Motivational Salience, because a couple of these paragraphs do an excellent job of summarizing just a ton of the research. Motivational salience is a cognitive process and a form of attention that motivates or propels an individual's behavior toward or away from a particular object, perceived event, or outcome. Motivational salience regulates the intensity of behaviors that facilitate the attainment of a goal, the amount of time and energy that an individual is willing to expend to attain that goal, and the amount of risk that an individual is willing to accept while working to attain it. All right, that was the first paragraph I wanted to read. While I was looking at the research on this concept, which was a new concept to me, I'd never heard of incentive salience, I came across an article with a great title, How Dopamine Tells You It Isn't Worth the Wait. The piece appeared on ScienceDaily.com in October 2017, and it shared research from the University of Texas at San Antonio. Their summary sentence was, a new study sheds light on how dopamine cells in the brain signal the passage of time. I will attempt to summarize the article for you in a delicious, attention-grabbing way. The research appears to show how the activation of dopamine corresponds to our desire for whatever we are waiting in line for example, whether it's coffee or a burrito. And we use waiting in line here as like symbolic of we know we're waiting for something, how long is it going to take? If our anticipation and desire for the given reward is high, dopamine will keep us motivated to stay in line. We feel good, excited, even a little high about our pending treat. And any new obstacles that should impede our progress or attainment can be overcome as our brains stir up memories and sensations of our beloved coffee or burrito and release more dopamine to keep us happily waiting in line as if time stood still. But if the memories, feelings, and associations that inspire our dopamine messages about that prize are weak, we won't feel like waiting. We lose interest, become distracted, maybe even a little sad, and then decide it's better to go somewhere else or go without. Or maybe we're feeling pressure to be somewhere else, and so our brain shuts off dopamine and lets us experience the anxiety of that other, more pressing motive. By the way, can you see the logo of your favorite coffee or burrito place in your mind? You probably can. It's burned into your brain for a reason, and the mere sight of it activates some level of dopamine, just like the sights or smells of Grandma's cookies. All right, back to this second paragraph I wanted to read on Wikipedia on the page for motivational salience. Incentive salience is a cognitive process that confers a desire or want attribute, which includes a motivational component to a rewarding stimulus. Reward is the attractive and motivational property of a stimulus that induces appetitive behavior, also known as approach behavior and consumatory behavior. Obviously, these are the scientific terms here. The wanting of incentive salience differs from liking in the sense that liking is the pleasure that is immediately gained from the acquisition or consumption of a rewarding stimulus. The wanting of incentive salience serves as a motivational magnet quality of a rewarding stimulus that makes it a desirable and attractive goal, transforming it from a mere sensory experience into something that commands attention, induces approach, and causes it to be sought out. Well, that makes the whole attention and reward business sound like a physiological event, potentially spanning hours, even if the final destination is just a 30-minute encounter with your coffee, your burrito, or your date. I thought these Wikipedia paragraphs under motivational salience were really good at summarizing the research. Obviously, you can go to the pages on Wiki and see all the research references and notes if you want to see where the actual scientific studies that were compiled to write the article. So the paragraphs get across these important ideas pretty well, but they leave out one key ingredient. I'll explain in a moment. So, to wrap up this little section on incentive salience, let me summarize and translate. I would directly translate the term incentive salience as reward attention, or pleasure focus, or even desire motive. So I'm doing a direct translation of the two words in the order they're in. Now, pleasure focus has the best ring to it, sort of, but I like reward attention better as it gets the best concepts across in a better way. I am leading up toward a way to remember the importance of this whole dynamic that will serve you well for the rest of your life. But if this brain dynamic or process that scientists are calling incentive salience is so important, why have most of us never heard of it? Because we are still learning so much about the brain every year, and getting the great neuro experts like Antonio Damasio, Michael Gazzaniga, or Steven Pinker to explain the research in simple terms we can understand is no easy feat. I mean, first of all, it takes them a while to write a book, and then do we actually read the book and do we understand it? And these experts, even if they grapple, even they themselves grapple in awe with the amazing complexity of the brain as they try not to reduce human nature and behavior to simple mechanical operations. I should add other great brain researchers like Candace Pert, who is no longer with us. She passed away in 2013. Joseph Ledoux, and, of course, Daniel Amen, who I mentioned before. And to really talk effectively about this reward attention system, you have to bring in multiple parts of the brain that are working with dopamine to get the job done. Incentive salience does at least 3 information processing tasks right away that involve a dozen parts of the brain at once. First, it alerts us to the available reward. Second, it signals the value of the reward to us based on our memories and experience. Third, it reviews or instantly deploys the motivating action required for attainment. Think of a jaguar whose brain and stomach are telling him he's hungry and it's time to hunt. If memory serves the jaguar, who learned to hunt from his mother and may have years of experience, chasing down a certain type of prey that he has just spotted may require a certain burst of energy. And so in comes a shot of adrenaline or norepinephrine. And just as it happens automatically for the jaguar, so too in us. Notice I mentioned memory again, while the Wikipedia entries for salience did not. We'll come back to this key ingredient. In short, as dopamine is involved in seeking and finding rewards, it appears to be the mediator of attention, desire, and motivation more than pleasure. But pleasure or feeling good can happen as a byproduct of pursuing what we desire. Just think of merely practicing a favorite sport or musical instrument or looking online for a date. Even if we are not very good or accomplishing much that could be called skill, our interest and desire have to be piqued or we wouldn't even bother. This is also dopamine at work. To really get across the effect of dopamine before a reward is actually attained, just think of the little high that addicts get even before they take their first hit, or the bigger rush of gamblers and other adrenaline junkies as they are on their way to the tables or to some cliff to challenge gravity in some way. Heck, I see this every day in the convenience store where people line up at a lottery machine to play a dozen different combinations of their favorite numbers in Pick 3 and Pick 4 daily games. The rush of getting their numbers is what motivates them to wait in line and read them all off to the cashier. Or how about the buyers of $20 scratch-off tickets? Do you think that they've done the math and found favorable odds in certain games? Like if they buy 10 in a row off the same spool to increase their chances of hitting a winner? Or are their brains also seduced by the activity of taking a coin and scratching off the brightly colored tickets in an endless, delicious menu of potential lucky prizes, like opening presents at Christmas? And how about the extreme dopamine rushes for the bungee jumper or the bank robber? Both risk their lives for different sorts of thrill. Did you see the film The Gambler with Mark Wahlberg? It's a terrific window into self-sabotage, as he would rather live for the thrill of a big bet than to be rational enough for self-preservation. I'm not much for casinos, but get me inside of a bookstore or library, and my brain is on high alert. So it sounds like the salience was the perfect word choice for this nuance in the study of motivation, because it's all about where our attention goes and stays focused, and for how long and how intensely to acquire a given reward, however irrational that prize may be in the long run. But this is not a linear process by any means. Dopamine is a big part of it, but it's complicated and requires that we talk about how different brain structures and functions work together and in tandem to create the cerebral symphony that we call consciousness. I'm going to take a break here, and we'll come back and hear from one of my favorite brain experts, Dr. John Ratey of Harvard. I'll be back faster than you could spell Cerebral Symphony. Before incentive salience became the textbook terminology, I simply learned about dopamine as the attention drug from the Harvard Medical School psychiatrist and brain expert, the two are not the same, Dr. John Ratey. I should be clear that Ratey didn't call dopamine the attention drug. That's just what I'm calling it now after doing more homework on it and with his help. By the time we are done today, I'll be calling it the attention memory learning drug, AML. Ratey became something of an authority on the attention aspects of consciousness after writing 2 books in the mid-1990s that were focused on the neurobiology of ADD and ADHD. The books were Driven to Distraction and Answers to Distraction. I shared some of the wonderful professor's excellent 2001 book, A User's Guide to the Brain, in an episode from August 2017 titled, What You See and What You Get, The Neurology of Perception. In the article version of this podcast that appears on Zax.com, I will link to a TED Talk by Dr. Ratey that you must take time to watch soon. I just found it this month, and what a treat to hear him speak and present his life's work with such joy. I thought I should find out what he's done since his 2001 book, and it's exciting stuff. I'll explain and tie it into dopamine coming up. In A User's Guide to the Brain, Ratey introduced me to the work of Dr. Kenneth Bloom at the University of Texas, who identified a pattern in addicts called reward deficiency syndrome. Now, before your brain turns off and you stop listening because I said the word addicts, and this certainly doesn't apply to you, listen to 2 things. First, as with anything we know about the body and brain, scientists learn from disease. Possibly half of the knowledge we have of anatomy, physiology, and neurochemistry comes from first studying what wasn't working for a patient, physically or psychologically. A perfect example would be what Dr. Ratey has learned about the brain that helps all of us by his studies of those affected by ADD and ADHD. In other words, we learn more about order by studying disorder. Second, by the time I finish this section on dopamine, you will have a new tool for learning any new skill or subject that will greatly enhance your life. Reward deficiency syndrome was identified by Kenneth Bloom's team as they unraveled the mysteries of dopamine and its corresponding genetic drivers. Bloom is credited with the discovery of both the locus of dopamine production in a brain structure called the nucleus accumbens and the gene associated with dopamine receptors. Let me read from Ratey's A User's Guide to the Brain, and we'll put the pieces of the dopamine puzzle together. The role of neurotransmitters. The structures of the attention system make use of various neurotransmitters, as does all of the brain. Serotonin and norepinephrine are important, but the system is most heavily dependent upon dopamine. Although the specific functioning of dopamine remains somewhat of a mystery, evidence suggests that it has 2 seemingly conflicting duties. It decreases spontaneous neural firing, which slows random noise, but it also has a depolarizing effect on neurons that makes them more ready to fire. Thus, it has been called the learning neurotransmitter. The depolarizing effect of dopamine is especially interesting because it may represent a link between the reward, novelty detection, and executive functions, and also between the overall attention system, learning, and memory. It is essential to the formation of long-term memories. Dopamine strengthens the prolonged chemical firing of messages between neurons and allows for unfettered communication between neurons. Conceptually, this results in the ability to formulate new concepts by forging links between old elements of knowledge, memories, essentially, which allows one to identify novel objects as opposed to those previously encountered in a given environment. Dopamine may be the link between rewarding sensations of pleasure and long-term memory. This learning neurotransmitter may also be the link between the motivational reward and motor systems. Problems with working memory, a form of short-term memory, correlate highly with dopamine deficiencies. And it is working memory that enables us to maintain continuity in our attention from one moment in our daily lives to the next. So he's already, just in those few paragraphs, Rady has created this, this loop that stands out, that dopamine creates attention, which creates memory, which creates learning, and it just keeps going. Even though he talks about dopamine having these conflicting roles, but it's that sort of tension, that is part of this loop of creating attention, memory, and learning. Let me get into the genetic aspect here, because that's where he brings in Bloom. The effect of genes. We are becoming increasingly aware that genes, too, play a role in attention. For example, the attention system involves distinct contributions from dopamine, the enzymes that make it in the nerve cells, its binding sites on the postsynaptic side, its transport mechanisms, and its metabolism. Each of these components has its own gene to guide the production of the proteins involved in these functions. One of these, the D2R2 receptor gene, which codes for the D2 receptors on the postsynaptic site for dopamine that is mainly concentrated in the area of the limbic system, has an allele, or basically an alternative gene, that has been linked repeatedly with a variety of psychiatric conditions such as alcoholism, ADHD, cocaine abuse, nicotine addiction, better known as smoking, compulsive gambling, and other addictions. These findings remain, but a number of studies now show that there is a relationship, and by relationship he means association, not a causal connection, between the D2 receptors and problems with reward and attention. It is believed that abnormally low density of D2 receptors in the nucleus accumbens reduces an individual's ability to experience pleasure. This diminished capacity would almost inevitably drive that individual to seek external forms of self-gratification. During the course of a life, such strategies could settle into pathological patterns of reward seeking, from substance abuse to sexual conquest to problem gambling. This has led Dr. Kenneth Bloom at the University of Texas and others to define a new syndrome called reward deficiency syndrome. And we'll get back to this because this is not, it's not in the DSM, which is like the Bible of psychiatry. Back to Rady here. Recognizing that a reward you are receiving is enough is in part a function of memory, and sustaining attention is the primary gateway to the encoding of memories. Thus, dopamine is central to both attention and reward. What's more, substances such as nicotine, cocaine, chocolate, marijuana, carbohydrates, and alcohol increase the level of dopamine in this area of deficiency. So searching for and ingesting these substances may be in part an attempt to compensate for individual differences in dopamine levels. These levels may also be increased rapidly by engaging in high-risk behaviors or by constantly confronting novel and challenging situations. Putting yourself at prolonged risk, say by climbing a rock wall or driving a dirt bike at high speed through unknown woods, demands that your attention system remain on full alert for long periods of time, forcing the sustained release of dopamine. So that people who seek that kind of rush what are they experiencing? Super alert, super focused, and they're getting high off of that too. One more paragraph here because this ties into Bloom and the genetic aspects. The D2R2 allele, although present in only 20 to 25% of the American population, was found to be present in 70% of severe alcoholics dying from cirrhosis of the liver. These findings, presented to the public in 1990, stirred up a flurry of debate in the media, which immediately jumped to the conclusion that the alcoholism gene had been discovered. Despite the researchers' insistence that they had in no way found a gene that causes alcoholism, a series of independent replication studies were performed to further investigate the findings. Although these studies have thus far yielded mixed results, 14 independent studies have supported the findings. So, what I wanted to say about Bloom's work and reward deficiency syndrome, he came up with that in 1996, and the term has been applied to a wide variety of addictive, obsessive, and compulsive behaviors, including substance and process addictions, personality, and spectrum disorders. But reward deficiency syndrome is not a medically recognized disorder. The diagnostic validity of RDS has never been recognized by the American Psychiatric Association in its diagnostic manual, the DSM. All right, I want to go back to Rady because this is also, we tie in something here with Parkinson's disease. So, as if what we're talking about with the brain and dopamine isn't complicated enough, Parkinson's is a great example of disease that can teach us that it's associated with movement too. So Parkinson's results from cell death in the substantia nigra, which produces dopamine and sends it to a second brain structure called the striatum, which coordinates movement. No dopamine means no muscular coordination. And so that's what you see in Parkinson's patients when they're in their 50s, and it's just their movement changes, and there's a sort of a degeneration of muscle control. One way that I learned more about Parkinson's was by investing in and following a company called Acadia Pharmaceuticals. The symbol is ACAD. They make a drug which just treats the psychosis aspect of Parkinson's. Because this dopamine deficiency is affecting movement, then there might be other treatments to restore dopamine for a Parkinson's patient, but those swings of dopamine and the treatment can create other psychological stress for those patients. So, this is how complicated and intertwined DOPA is with our experience and our brains. I want to read one more section here from the good Dr. Rady, and this is about it's titled Joy. How do we experience joy? It is both the physiological experience of warmth and satisfaction and the cognitive assessment that this is the way things should be. Joy, happiness, pleasure is its own incentive. It's what makes survival and propagation of the species worthwhile. Some of the earliest research on happiness was serendipitous. In the 1950s, James Olds and Peter Milner, hoping to influence learning, placed an electrode into the hypothalamus of a rat. When the rat pressed a bar connected to the electrode, the hypothalamus was stimulated. The researchers concluded that the rat perceived this sensation as pleasurable because it proceeded to press the bar up to 4,000 times an hour and would allow itself actually to starve rather than stop pressing. So obviously they'd hit upon the pleasure center of the brain. Since then, research with humans has shown that the hypothalamus is just one of several pleasure centers of the brain, among them the septum and the nucleus accumbens, which we've talked about. Neurotransmitters and endorphins play an important role in the perception of pleasure, but dopamine is the key factor. Each of the pleasure centers uses dopamine as a transmitter. If a rat is trained to push a lever for internal stimulation to a pleasure center and is then given a drug that blocks the action of dopamine, the rat will stop pushing the lever. Pleasure is often muted in people who are taking conventional antipsychotic drugs which block the dopamine receptors. The drugs are used to stop hallucinations and delusions, but often produce a state of joylessness and a lack of motivation and drive. And as this can complicate treatment, newer drugs that have less of this effect are being developed to treat psychosis. Now, again, this is Rady writing in, say the year 2000, and I'm sure there's a whole suite of drugs that are being worked on in these areas. I mentioned the one from Acadia for Parkinson's. Meanwhile, drugs such as cocaine and amphetamines work in the brain by increasing dopamine levels. But if dopamine or any of its artificial substitutes reaches levels that are too high, hypomania or even mania can result. It is hard to imagine a disorder arising from too much happiness, but there are several that can result from not having enough happiness or enough internal reinforcement and feelings of pleasure. Reward deficiency syndrome, the concept coined by Ken Bloom at the University of Texas, is helpful in understanding the complexities of addiction and compulsive behavior. The idea states that a lack of internal rewards, in essence, proper dopamine functioning, leads a person to self-medicate with substances or with behavior that is rewarding. In other words, rewarding meaning creates massive extra stimulation to get any kind of dopamine going. This is Rady again. We see evidence for this in the statistics for conduct disorder and ADD. Children who have either of these illnesses are 5.5 times more likely to be addicted to drugs or alcohol as adults compared with the general population. While different neurotransmitter systems cascade upon one another in the reward mechanism of the human brain, perhaps the most important interaction is that of dopamine in the nucleus accumbens, the group of neurons that have a special relationship to reward and motivation. The nucleus accumbens is located just beneath the front of the striatum at a part of the basal ganglia, which is involved in movement and cognition. If the nucleus accumbens is lesioned in lab rats that normally push a lever to receive addictive drugs such as cocaine, the rats will stop pushing. So that's some of the basic research that Rady was familiar with when he put together that book, and it's given scientists and researchers plenty of room to run and do new experiments to confirm that. But I haven't seen. It seems like I've come across more or less the latest research on dopamine. There's probably some stuff out there I haven't seen, but I think that we can put together this idea that dopamine is definitely the attention drug, but I want to take it a step further and call it the attention, memory, learning drug. And so attention is a complex system, so we're going to pan out a bit from dopamine and get a wider angle on it. Keep in mind that the mind can be studied as discrete parts and functions and neurochemical interactions, but there are endless connections between all of these on multiple levels that really create what the theoretical neurophysiologist William Calvin called the Cerebral Symphony. I'll be talking more about Professor Calvin in upcoming episodes, but this hits on my idea of the multi-mind that there's so much going on at once, and so we would like to think that our behavior and our consciousness creates a concert, but it's often a noisy concert. Rady describes the loop of what's happening when we pay attention with 4 words: arouse, orient, detect, and execute. And I just want to read this one paragraph where he's sort of summing up the research there. Scientists have identified 4 distinct components within the attention system, which together create the brain's overall ability to monitor the environment: arousal, motor orientation, novelty detection and reward, and executive organization. And so he sums those up as arouse, orient, detect, execute. So, remember that so much of this is happening on a subconscious level in the lower brain centers, from the brainstem to the complex midbrain area that used to be called the limbic or neo-mammalian system, and which includes structures like the thalamus, hypothalamus, amygdala, hippocampus, cingulate gyrus, and nucleus accumbens. Neuroscientists, some of them, don't talk about a a limbic system per se anymore because it's so much more complicated to describe the interplay of multiple areas of the brain in stimulus, attention, emotion, memory, and motivation. The reptilian, mammalian, and human neocortex and language centers are all working in concert. Well, almost. And so you can think of there's bottom-up processing going on where we're receiving automatic information from lower brain centers, like under the level of consciousness. And, that might be memory-free if it's new information. And then there's top-down, which, our conscious neocortex is actively engaging with memory and anticipation mechanisms. So this all leads us to the problem of focus. If it's kind of a noisy concert, and we're not always playing music well in our Cerebral symphony, then this might explain why we have trouble focusing. Rady does a great job of talking about more of this and how the emotional tagging aspect comes in with dopamine. Emotional tagging would be, we're assigning importance to something. So the last thing I want to share about Rady is his newest project. He's written a book called Spark. And now it's been around for a few years, but what he's been working on is teaching kids and adults that exercise is like the key to a healthy brain. That's what your brain wants to get high. Your brain would rather get high playing sports, running, or doing some activity you love than just about anything else. And if you do that, the effects are huge. And I think any athlete can attest to that. So this leads me to my conclusion for today about how to learn more, better, and faster. And based on my theory of calling dopamine the attention, memory, learning drug. When you think about where, what are the words we use to describe people when they're functioning at super high levels? We talk about being in the zone or being in flow. So where does that come from? Because that would seem to be where you've really got a cerebral symphony going on and not some noisy concert where you're in flow or in the zone and everything seems to be working together. Your body, your mind, subconscious, your ability to concentrate, your skill level, your creativity, and nothing can bother you, nothing can interrupt you. When athletes, artists, musicians, scientists, speakers are in the zone or in flow, it's really hard to disrupt the symphony that's going on for them. So here's my 5 ways to learn more, better, and faster. Number 1, pick a special place. I have a place I like to go by a lake on a hill, which is beautiful, especially in the summertime. And so when I'm doing any kind of reading or writing there, I remember it better because I'm in that place where my senses are stimulated. It's beautiful. And I'm sure the same would be true for a musician, artist, athlete to enhance their learning or skill development. Number 2, make it 3D. Create something that you can touch or use with whatever you're learning, whether it's a physical model or blow up whatever you're studying. Like, so if you're studying something about the brain, make it bigger and walk a path on the ground of what you're studying or draw it. So make anything that you can make physical and touch or have it be an experience. And I'll expand on that in a moment. Number 3, obviously make it visual and auditory, sight and sound. We talk about people being primarily visual learners, primarily auditory learners, that kind of thing. But I think, you can find which one works for you, but use them all. Number 4, movement. I touched on this a little bit with 3D, but just do it. Turn a concept into action. Now, you think about athletes who practice their sport and have certain drills. They drill because that creates muscle memory. Well, you can do the same thing with any kind of subject you're studying. All of these things that I'm doing are to get people out of textbooks, so to speak, because you can only learn so much staring at a textbook with a yellow and pink highlighters and expect to remember it. It's creating different ways for your brain. Like your brain is a mental gym. So if you can get it to have multi-dimensional experience with whatever you're learning, it works better. And the fifth and final way, which might be my favorite, is stories. I've been working on a math book for teens that's what I call story-based mathematics, meaning not every kid wants to sit and look at a textbook full of equations. It's not the way to learn math. The way to learn math is with a story, with movement. Make it visual, make it 3D, and do it in some place special so that it's memorable. And that's what I found worked for me with math. So I call this my little theory. Since I'm calling dopamine the attention memory learning drug, AML, I thought, well, how am I going to remember that acronym? I love to use acronyms to remember things. And I found a better acronym, and we'll tie this back into Alzheimer's. The cause of Alzheimer's, one of the proposed possible theories about the cause of Alzheimer's are these protein plaques that sort of crowd out and corrode neurons in the brain and basically stop function and create dementia, loss of memory, that kind of thing. And the names of these proteins are called amyloid, AMYLOID, amyloid. And it's actually misnamed because AMYL is like a carbohydrate base, and that's what they originally thought these amyloid plaques were, or amyloid was, that it was carbohydrate based, but it's actually protein based. So AMYL, I'm going to make stand for attention, memory, yearning, and learning. So if you want to prevent Alzheimer's, then use AMYL in a positive way: attention, memory, yearning, learning. I mentioned Mickey Hart of the Grateful Dead. What he's working on, he's using music to prevent Alzheimer's. So Rady would like to enhance people's brains with the focus on exercise. Mickey Hart obviously is going to use music and percussion, and he's given concerts in the past few years where he'll have sensors hooked up to his brain, and they broadcast it visually on a screen over people watching the concert so they can see what parts of his brain are lighting up when he's playing the drums and he's in his flow zone, so to speak. So my AMYL, my amyloid solution for learning, I think it solves the motivation problem because it challenges you to turn all of your goals into games and learning opportunities. I mean, if you keep it fun and interesting, you are much more likely to stick with something and accomplish what you wanted to. And I also think of it as you learn to raise your attention, motivation, and reward levels, like what you expect, what you think you deserve in terms of reward levels. So for me, that's learning how to finish writing the 5 books I've started. In conclusion for today, we're not going to get to my 5 proofs that we are naturally irrational. We'll do that next time. That'll be I'll have do a separate thing on climate science and my 5 proofs that humans are naturally irrational, and we avoid good ideas and good science. But to wrap up with dopamine, we think we have no control of it and that it just works automatically like digestion or breathing. But I think now you can see that you can actually harness it. We tend to overreact to what others are doing and what's going on around us. And this completely distracts us from our long-term goals when we're focused on what other people are doing wrong or what mess is going on in the world. So if you understand how your brain works, then you understand focus and what it takes for you to achieve what you want. Understanding how your brain learns and using what we know about the many dynamics of dopamine, I think, is a game changer in education and goal achievement. It's how you get your internal weather favorable so that no matter what's going on around you, you can get where you want to go and get the rewards you seek. All right. I think I just did some justice to the wonderful dopamine, and I learned by teaching. and I think Richard Feynman would approve. All right. Thanks for joining me. Be sure to find the article version on Zacks.com, where I'll have all the links. All right. Talk to you soon.